In this project, I implemented the GLSL shader that combines transmissive and reflective effects on my 3D glass mug model that I showcased last assignment. I demonstrate reflection, refraction, Fresnel effects, and chromatic dispersion. I also use this cubemap that I downloaded and implemented. I like the graffiti effect and how it could show the different effects on the mug. So when I press key 1, you can see the reflection component only. The shader enters a debug mode that displays only the reflection component, and this means the shader computes the reflection vector and samples the cube map solely for the reflective color. This mode is important because it shows that that reflection is correct and that the skybox is working as expected. When I press 2, I go into the refraction. This only shows the refraction effect now. Here, the shader computes refraction by bending the view vector based on the refractive index and chromatic dispersion. As you can see, this model isolates the transmitted light through the glass material. And then when I press 3, I go into Fresnel visualization, and as you can see here, it controls the blend between reflection and refraction, and it really depends on the angle between the view direction and the surface normal. In this mode, the surfaces that are perpendicular to the view appear darker, while those glancing at angles between the view direction and surface are brighter. This mode is essential for confirming that the Fresnel calculation is correctly modulating. Then when I press 4, you can see the chromatic dispersion effect only. This is my favorite effect. It computes different refraction vectors for the green, red, blue channels by varying refractive index slightly. This produces a subtle color separation effect, similar to a prism split light. This debug mode is important because you can see that it demonstrates the shader correctly. So I placed these 6 mugs in various positions around the scene, each with a unique shader parameter value to illustrate the different optical properties. So the mug in the very center here, that is at a refractive index of 1.52, a dispersion of 0.02. The mug over here to the left, that is at a refractive index of 1.3, a dispersion of 0.01. This mug right here to the right has a refractive index of 1.6, a dispersive index of 0.03. And then behind over here, this one has a refractive index of 1.80. Let's see if I can get to it, and a dispersion of 0.05. And the one above has a refractive index of 1.90 and a dispersion of 0.08. So the scene's environment is defined by a cube map based on a skybox that I had an HDRI file that I converted into a cube map. And these 6 images split up into the cube map that's applied here, and the skybox is rendered first with a shader that ignores the translation in the view matrix. The skybox is rendered, and then the environment remains static relative to the camera. This environment texture is critical because it actually showcases the different features, as you can see more specifically here as I toggle around in my debug mode. The dynamic interaction between the mugs and the skybox, this creates a photorealistic appearance that enhances the glass effect of the mugs. Thank you.